All right, welcome back to the deep dive, everybody. We talk a lot on this show about all kinds of different gear and techniques for bow hunting, but sometimes we need to take a step back and really get down to the fundamentals.
Yeah, absolutely. And one of those fundamentals is definitely arrow setup. I mean, if your arrow isn't performing the way it should, all that other stuff doesn't really matter, right?
Exactly. And that's why we're diving deep today into the concept of front of center, better known as FOC.
You know, for a lot of folks, FOC can feel kind of like a black hole of technical jargon and confusing calculations, but understanding it can honestly make a huge difference in how your arrows perform in the field. And today we're going to break it all down, make it clear and understandable for both those brand new to the concept and the seasoned bow hunters out there.
So strap in, because we're about to get seriously nerdy. And to do that, we're going to unpack the findings of this super cool 2005 study that specifically investigated how FOC affects arrow penetration. And what's really awesome about this study is that it's not just some theoretical mumbo-jumbo. It's based on real-world tests. I mean, they actually fired arrows and recorded the data.
Yeah, that's what makes this research so valuable. It's not just speculation, it's hard evidence.
So to kind of set the stage for our exploration, let's start with this quote from Dr. Ed Ashby, the guy behind the study. In his update, he says, "It is essential for the listener to recognize that each update overviews reflects the study's findings at the time the update was written. Each overview represents findings which are built on all the prior information. With each test, we learn more about the factors affecting the real tissue terminal performance of hunting arrows, and with each test, new questions and new areas for future investigations always arise." So what he's saying is that understanding arrow performance is like this ever-evolving journey. We're constantly learning and refining our knowledge.
Right, and that's an important thing to keep in mind. This study was a significant step, but it's just one piece of the puzzle. And it laid the groundwork for even more research and understanding.
Okay, so before we get too deep into the weeds, let's make sure we're all on the same page. What exactly are we talking about when we say FOC?
Well, the study lays it out pretty clearly. FOC stands for the weight forward of center and measures how far the arrow's balance point is forward on the arrow shaft's center point.
Okay, so basically it's about where the weight is distributed along the arrow shaft, right?
Hmm.
Like if you think about balancing a ruler on your finger, if you add more weight to one end, the balance point shifts.
Exactly. It's all about that balance point.
Yeah.
And based on their testing, the researchers divided FOC into three distinct categories. And these weren't just random categories. They were based on observable changes in how the arrows performed.
Gotcha. So what were these categories?
Well, the first one is what they called normal FOC, and that's anything up to 12%. The study mentions that this level of FOC is obtainable with many common shafting materials. So most off-the-shelf arrows you'd pick up would probably fall into this category.
Okay, that makes sense.
Okay.
So what about the next category?
That's high FOC, which the study defines as being between 12% and 19%. And it's important to note here that this high FOC is a term specific to this study, okay?
And what about achieving this high FOC? Is that something that most bow hunters can do with their setups?
Oh yeah, definitely. The study points out that high FOC is achievable with most shaft materials through the use of lower shaft weights, heavier broadheads, and higher shaft footings. So there are different ways to tweak your setup to get into that high FOC range.
Cool. But there's also this line in the study that says the 19% upper limit for high FOC is based on the point at which the focal testing outcomes showed a clearly defined change in penetration characteristics. What does that mean exactly?
It means they observed a noticeable shift in how the arrows were penetrating once they hit that 19% FOC mark. So it wasn't just a random cutoff point, it was a performance-based threshold.
Okay, so that takes us to the third and final category. And I'm sensing this is where things get interesting.
It is. This is what they called extreme FOC arrows, and these are the ones with 19% FOC or greater. And let me tell you, the study makes some pretty bold claims about this category. They say, in our testing, using arrows identical in all aspects except the degree of FOC, the first measurable increase in penetration due solely to arrow FOC was found to be at the 19% level. So that's suggesting that crossing that 19% threshold could really make a big difference in how your arrows perform, particularly in terms of penetration.
Wow, okay, so how do you actually build an arrow to achieve that extreme FOC?
Well, according to the study, achieving 19% or greater FOC requires using a significant weight at the front of the shaft and a reasonably light shaft weight relative to the points weight. So you're basically front-loading the arrow, but you got to do it carefully to maintain a good overall weight balance.
Right. And they also mentioned that there's The formulas for calculating arrow FOC is in the study update text. So if you really want to get into the nitty-gritty, you can check out the text.
But for the sake of this deep dive, I think the main takeaway is just understanding the concept of weight distribution.
Totally. Now, what about the folks out there who are shooting arrows made from materials other than carbon? Does this whole FOC thing apply to them as well?
Well, the study does have something to say about that. They observed that due to shaft mass and flexional characteristics, achieving extreme FOC with any shafting other than carbon is extremely difficult while maintaining good arrow flight characteristics. So it seems like carbon shafts might be the way to go if you're really serious about hitting that extreme FOC and keeping your arrows flying straight.
Gotcha. Now, let's talk about why this whole FOC thing matters. Like, why would having more weight at the front of the arrow potentially lead to better penetration?
Well, here's how the study explains it. The rationale for the penetration gain is that with most of the weight towards the arrow's front, there is less weight towards the arrow's rear to cause shaft flexion at impact and during penetration.
Okay, so break that down for me. What's shaft flexion and why is it a bad thing?
Shaft flexion is basically just the arrow bending or flexing when it hits the target. And it's not ideal because that bending absorbs some of the arrow's energy, which means less energy is directed towards penetration.
So by having more weight at the front, the arrow is more resistant to bending, right?
Exactly. It's like the heavier front end wants to keep moving forward in a straight line, and there's less mass in the back to cause it to wobble or flex.
Okay, that makes sense. And the study actually uses a really cool analogy to explain this. They say, you can think of it this way. With extreme FOC arrows, the arrow shaft is pulled through the tissues by the heavy weight of the point. With normal to high FOC arrows, the arrow's point is being pushed from behind by the weight of the shaft.
I love that analogy. It really helps to visualize what's happening. It's like if you're trying to pull something through a thick bush, it's a lot easier to pull it from the front than to push it from behind and try to keep it straight.
Exactly. And they even take it a step further with this awesome string example. A good analogy can be demonstrated with a piece of string. Lay a string on the floor and pull it along by one end. It pulls smoothly in a straight line. Try pushing it from the back, and it bends. Though stiffer and bending far less than a piece of string, an arrow shaft shows the same effect, just to a lesser degree. I mean, that's a perfect illustration of how FOC affects the arrow's behavior upon impact.
And this whole idea of shaft flexion being a major factor in penetration is something the study emphasizes really strongly. They say, without a doubt, shaft flexion at impact and while penetrating is a significant factor in the resistance impulse exerted by the tissues upon the arrow. So the less your arrow bends, the better it's going to penetrate.
Makes sense. Now let's talk about how they actually put these ideas to the test. What did they do to actually investigate this whole extreme FOC thing?
Well, they conducted a series of 3 tests, and each one was designed to compare different arrow setups and see how FOC impacted penetration. And in the first test, they used sets of identical carbon express shafts mounted with 145-grain Eclipse broadheads, with tips modified to a cut-on-contact Tanto tip profile. Broadhead edges were finished shaving sharp with honed and stropped edges. And this is all just to say that they went to great lengths to make sure the broadheads were consistent across all the arrows, so that wouldn't affect the results.
Yeah, that's super important. So what kind of arrows did they actually build for this first test?
All right, so for the normal FOC group, they used a double shaft with a Beam & Hunter shaft inside the Carbon Express and fit with aluminum broadhead adapters, giving 10.3% FOC and a mass of 840 grains. So that's a pretty standard setup, a good weight with normal FOC.
Gotcha. And then for the extreme FOC group?
These they made by forward weighting with 185 grains of Oro steel rod back of the insert, plus 125 grain steel broadhead adapter, giving 24.3% FOC with a mass of 847.5 grains. So they got that FOC way up there while keeping the overall weight pretty close to the normal FOC arrows.
Okay, I'm seeing a pattern here. They're trying to isolate the effect of FOC, right? Like keeping everything else as consistent as possible.
Exactly. And then to really round things out, they also included a third test set of carefully matched tapered hickory shafts mounted with the Eclipse broadhead, each weighing an average of 840 grains with an extreme spread of 7.5 grains. These had an FOC of 10.02%. So this is a more traditional arrow material, but with a similar weight and FOC to the normal FOC carbon arrows.
Okay, I'm with you. So what happened when they actually shot these arrows?
All right, well, the results were pretty clear. The Extreme FOC Carbon Express showed a 19% increase in average penetration over the double-shafted normal FOC Carbon Express and an 18.24% increase over the tapered hickory shaft.
Yeah.
So right off the bat, we're seeing that higher FOC translates to deeper penetration, even when the overall arrow weight is similar.
Wow, that's a significant difference. And the study goes on to say each shot with the Extreme FOC arrows reached the offside rib. One penetrated the buffalo's offside rib, and another had most of the blade protruding through the rib.
I mean, that's some serious penetration, especially when you're talking about hitting bone.
Yeah, definitely. So on to test series 2. In this one, they took 2 identical sets of Carbon Express shafts. Again, trying to control for all the variables except FOC. Right. And for the normal FOC arrows, they used weight tubes, 2 sections of 2.7 millimeter weed eater line, a hollow aluminum BH adapter, and 125 grain grizzly broadheads for a mass of 689.3 grams and FOC of 11.8%. So a bit lighter overall compared to the arrows in the first test, but still within that normal FOC range.
Yeah, and for the Extreme FOC group, they went with 125 grain steel broadhead adapters and 145 grain grizzly broadheads. The 125 and 145 grain grizzly broadheads have identical physical dimensions except for blade thickness. This gave them a mass weight for the second set of 682.3 grains, and the FOC was 20.4%. So again, for the lane to my seat here, what were the results of this second test?
Oh man, they were dramatic. Hold on to your hat. The Extreme FOC arrows averaged 62% more penetration than the normal FOC arrows.
Whoa, 62%. That's insane. That's like a totally different ballgame.
Right. I mean, imagine what that could mean for your hunting success. That's a much higher chance of getting a clean, ethical kill. Absolutely. And they also observed this crazy difference in rib penetration. They say no shot with the normal FOC arrows reached the offside rib. Every shot with the Extreme FOC arrows reached the offside ribs. I mean, that's a complete 180.
It really highlights how FOC can affect your arrow's performance, especially when it comes to punching through bone and getting into those vital areas.
Now, they did mention that this huge difference in penetration compared to the first test might have been partly due to the broadhead design. They say the massive difference in penetration increase shown in the Set 2 testing when compared to that shown in the Set 1 testing is a result of the grizzly broadhead's much higher mechanical advantage compared to the mechanical advantage of the Eclipse broadhead. A broadhead having a higher mechanical advantage makes more efficient use of the conserved force resulting from the higher FOC arrow's reduced shaft flex.
So it sounds like finding the right broadhead to pair with your high FOC arrows is super important.
Totally. And this all leads to the third and final test. In this one, they switched things up a bit and used epic shafts. Okay, cool. And for the high FOC group, they went with internally weighted with 2 pieces of 2.7 millimeter weed eater line and fit with an aluminum broadhead adapter and 150 grain grizzly broadheads for a weight of 643 grains and 15.6% FOC.
Right. And then for the Extreme FOC group, it was fit with 125 grain steel broadhead adapters and 190 grain grizzly broadheads, giving a weight of 620 grains and FOC of 25.3%. As with the 125 and 145 grain grizzly broadheads, the 160 and 190 grain grizzly broadheads have identical profiles but differ in blade thickness. Now, it's interesting to note here that the Extreme FOC arrows in this test were actually lighter than the high FOC arrows.
Yeah, I noticed that too. So what happened in this final showdown?
Well, the results continue to support the idea that higher FOC means better penetration. The Extreme FOC arrows average 58% greater penetration than the high FOC arrows. So even compared to an arrow that was already in the high FOC range, the Extreme FOC arrows still pulled ahead.
Wow, okay, so it seems pretty clear that FOC has a big impact on penetration. But this test also brought up another important point. They say the onside ribs stopped 50% of these lighter weight arrows. A threshold minimum arrow mass for consistently breaking heavy bone exists in the vicinity of 650 grains, which is more of a function of the impulse time than the degree of applied force. It is a data feature that consistently surfaces.
So it sounds like while FOC is important, you can't go too light on the overall arrow weight, especially if it might hit bone.
Right, you gotta have enough mass to power through.
And
they go on to explain, both arrow sets in this series showed difficulty penetrating the entrance rib, showing a bone breaching rate of 50%. This failure to breach the entrance side ribs is attributable to the lower arrow weight compared to those used in Series 1 and 2 testing. Lower arrow weight means the arrows will have a lower impulsive force, which measures how long the arrow can push forward. So even with a high FOC, if the arrow is too light, it might not have enough oomph to break through bone. And they explain this further, saying, before an arrow can begin bone penetration, the arrow's force must overcome all bone movement and flexion. Once the arrow overcomes bone movement and flexion, it must retain sufficient momentum to penetrate entirely through the bone. Arrows of this weight could not exert the force they carried at the moment of bone impact for enough time to overcome the movement and flexion of the rib with sufficient retained arrow force to breach the now immobile bone. Man, there's a lot going on there.
Yeah, it's pretty complex. But the bottom line is that there's a balance to strike between FOC, overall arrow weight, and the specific characteristics of the target you're shooting at.
Totally. Now, based on all these tests, what did the study conclude about how FOC affects bone penetration and what happens after the arrow gets through the bone?
Well, their overall conclusion was this. Test results suggest that the amount of arrow FOC does not affect an arrow's ability to penetrate bone. However, it is also suggestive that the amount of arrow FOC does lead to increased post-breaching penetration. FOC's effect on post-breaching penetration will be a focal point for future testing.
Okay, so basically, FOC might not be the deciding factor when it comes to initially breaking bone, but once that broadhead is through, FOC seems to play a big role in how deep the arrow penetrates.
Exactly. And after those planned tests, the author kept experimenting with all sorts of different extreme FOC arrows. He says, after completing the pre-planned series of focal tests, I tested many other extreme FOC arrows. Except for one set of lightweight arrows weighing 620 grains, every extreme FOC arrow penetrated deep enough to reach the offside ribs, and 4 shots achieved exit wounds.
And the data they got from all that additional testing is pretty wild. They say 92% of the extreme FOC shots reached the offside ribs, 41% penetrated the offside rib, and 10.3% gave an exit wound. And just so everyone's clear, penetrate the offside rib means the entire broadhead passed through the offside rib.
Yeah, that's some impressive penetration. And to put that in perspective, they compared it to field data from actual Asian buffalo hunts, where hunters were using normal and high FOC arrows. They found that in the Asian buffalo field records, there are 257 shots on buffalo with normal and high FOC arrows, which strike a rim on the entrance. Only 65 of these shots, 25.3%, reached the offside rib. Only 7 shots, 2.7%, penetrated the offside rib. None gave an exit wound.
Man, those numbers really speak for themselves. It seems like there's a huge difference in penetration potential between extreme FOC arrows and the more traditional setups.
Yeah, and it all comes down to that final analysis from the study, which says all indications are that extreme FOC arrows offer a substantial gain in arrow penetration, and that gain is first manifest at 19% FOC.
Okay, so let's break it all down for our listeners. What's the key takeaway from all this research?
Well, in a nutshell, this 2005 study provides some pretty convincing evidence that if you can get your arrows to that extreme FOC of 19% or greater, you're likely to see a significant increase in penetration. And that advantage seems to be especially noticeable after the arrow has punched through bone.
Now, before everyone runs out and starts building super front-heavy arrows, it's important to remember that FOC is just one part of the equation. There are a lot of other factors to consider when setting up your arrows, like broadhead selection, overall arrow weight, and how well your bow is tuned.
Oh yeah, absolutely. It's all about finding the right balance. But this study definitely highlights the importance of FOC, and it's something worth thinking about, especially when you're choosing your arrows and broadheads.
So listeners, based on what we've talked about today, we want to challenge you to take a look at your current arrow setup. What's your FOC? And could experimenting with a higher FOC potentially benefit your hunting?
And here's a final food for thought. We've seen how extreme FOC can lead to better penetration. But what about the other side of the coin? What are some of the potential drawbacks or challenges you might face when trying to achieve and use extreme FOC arrows in your own hunting? We encourage you to keep learning, keep experimenting, and find what works best for you. Thanks for joining us on The Deep Dive.
We'll catch you next time.